everybody, it's your girl PC in DC, and as you can tell by the title of today's video, I'm going to talk a little bit about viruses. And it just so happens that I'm just leaving my doctor's office too, so I just went in for test results. Everything's good. Excited about that. So, but yeah, a few days ago I was over at the Museum of Natural History, the Museum of Natural History, and there, to my surprise, the Smithsonian had an exhibit called Viruses. Number one, I wasn't aware that the Smithsonian built exhibits around current social issues, but I guess that's responsible on their part. And secondly, I thought for sure it was just going to be a lot of talk about Corona, what to do, what not to do, the whole washing your hands, you know, sneezing in your elbow kind of stuff, but it was a lot more than that. Actually, they spoke about pandemics in the past, influenza, MERS, SARS, Zika, and smallpox, a whole lot more. And basically, I think my takeaway from that exhibit is that there's no wall, there's no bubble around the United States, around Africa, around China, Russia. We are all interconnected. We all share this planet. We all share this globe. And basically, if there's an outbreak somewhere, I guess it really depends on how the wind blows as to where the next outbreak will appear. There was a lot of information in there about, you know, human to human pathogens, and then human to animal, animal to human. So it was really interesting. So if you're sensitive to that kind of thing, you might not want to watch this video. But if you're curious and you just want to, you know, see more, get a little more information, then continue watching. And what I'll do is I'll catch you in the next video. Take care. Bye-bye.
If a person was the size of a flu virus, they and almost half of the world's human population could fit on top of a pencil eraser. Yep, that's pretty small. Even when you get a good look at viruses, they are tricky to peg. They mutate and evolve at different speeds. Viruses have to replicate quickly and spread to as many host cells as possible before your immune system stops them. And spreading between hosts is pretty easy. It happens a lot of ways. The most common, good old-fashioned sternutation, or sneezing. Like it or not, many of us ingest and inhale millions of viruses every day. Usually we're fine, but sometimes we get sick. Take, for example, influenza. The flu virus, covered in little spikes, travels towards a host cell. These spikes attach to the receptors on the cell's surface. When flashed on, the virus is granted entry through the cell's membrane. The virus wastes no time releasing its genetic material into the cell. This hijacks the cell's reproductive system, forcing it to make millions of virus copies that leave the cell and spread to other parts of the host. To take command of a cell, the virus needs to be strong, but not so strong as to damage the cell's ability to function. It's a delicate dance for the constantly mutating virus. There's always a chance that a random mutation may help it survive. So our bodies put up a defense, which is aided by vaccines. The virus mutations require new flu vaccines to be developed every year, but researchers seek to develop a universal vaccine for better protection against all strains of flu. Still, vaccines that catch the virus at its source are difficult to develop. So keeping the flu bug at bay rests in our preferably washed hands. Keeping healthy and going to the doctor when sick is key. And when it comes to sneezing, remember, it's all in the elbow. No, seriously, it is. Put it in the elbow.